sheet on you, probability, a beginner's approach, is about, getting a first-hand exposure to very elementary situations on probability. Let me get you past this. First one is a very common problem. There is a leap year selected at random, and in that leap year, what is the probability that there is going to be 53 Sundays? A leap year is selected at random. We want to find the probability that there is going to be 53 Sundays in it. Now, how many days are there in a leap year? 366. Right? Which means 52 full weeks plus 2 days. Now, these 2 days would be obviously consecutive, and they could be, let's say, Saturday, Sunday, Sunday, Monday, Monday, Tuesday, Friday, Saturday, right? Yes or no? Now, what I want is 53 Sundays. So, in all, for leap years, these are the 7 types of leap years possible, isn't it? 52 weeks plus this or this, 52 weeks or this, 52 weeks or this. So, there are 7 types of leap years. There are 7 types of leap years in which the 2 additional days could be any one of these 7 possibilities, right? What we want is an additional Sunday. That means the favorable out of these 7 are these 2 in which we will have an additional Sunday. Yes or no? These are the 7 types of leap years in which the 2 additional days could be any one of these. But to have 53 Sundays, the leap year must be commensurate with this or this, Saturday, Sunday, or Sunday, Monday, to have 53 Sundays. That means out of these 7 possibilities, 2 possibilities, these are 2 favorable possibilities for 53 Sundays. Yes or no? Therefore, the required probability is going to be 2 by 7. 2 by 7. Yes or no? Would be the required probability. Clear? Now, let's look at the next one. Can I wipe this off? Huh? Why? No, but I have already selected the leap year. So, this is my sample space. I didn't want to talk sample space, but my sample space, a leap year is already selected. That means a leap year of one of these types is selected at random. That means the occurrence of a leap year is guaranteed. Right? So, it's not like if someone has said, what is the probability that this would happen without saying a leap year, then of course, then the probability of a leap year occurring first and a leap year of this type or this type would have appeared, right? Yes or no? And those would have been independent events, right? First of all, selecting a leap year, and then in a leap year, selecting one or the other type of the leap year. These would have been 2 independent events. Yes or no? Right? Is about a bag which contains 3 red, 6 white and 7 blue balls. What is the probability that the 2 balls drawn are white and blue? What is the probability that the 2 balls drawn are white and blue? First of all, that means the number of ways in which a white and a blue ball could be drawn. That means the favorable ways would be a white ball could be drawn in 6 ways, a blue ball could be drawn in 7 ways. So, 42 favorable ways of drawing a white and a blue ball, right? And the total number of ways of drawing 2 balls is 16C2. Are the total number of ways of drawing 2 balls 16C2, right? Total number of balls are 9 and 7, 16. Out of which if you want to draw 2, then these are the total number of ways of drawing 2 balls. Out of which how many are favorable? What's the favorable event? Drawing of a white and a blue ball. A white ball drawn in 6 ways, a blue ball drawn in 7 ways. So total favorable ways are 42. 42 divided by 16C2. So the required probability is going to be 42 divided by 16C2 would be the probability. Clear? No issues? No, they are not identical. They are not identical. We'll until and unless it's given that they are identical, we will assume that they are different. Now, 12 balls are distributed at random in 3 boxes. 12 balls are distributed at random in 3 boxes. These are the 12 balls. And there are 3 boxes. B1, B2 and B3. These are the 3 boxes. 12 balls and 3 boxes. Okay. What is the probability that and these 12 balls are randomly distributed in these 3 boxes. What is the probability that the first box contains 3 balls? We want to find the probability. We want to find the probability that this contains 3 balls. Okay. Okay. First of all, in how many ways can you distribute 12 balls in 3 boxes? 3 to the power 12. Because any of these balls could go in any one of the 3 boxes. B1 could be delegated in 3 ways, B2 in 3 ways, B12 in 3 ways. So the total number of ways in which these balls could be distributed in these boxes, total number of ways would be 3 to the power 12. In some of these cases, there would be 3 balls in B1. There would be 3 balls in B1. So let me find out the number of ways in which 3 balls could be given to B1. Right? So what I do is, out of 12 balls, there are 3 events. Giving 3 balls to B1 and distributing the remaining balls in these 2 boxes. Distributing the remaining 9 balls in these 2 boxes. These are the events to be taken care of. So 3 balls given to B1 could be done in how many ways? 12C3 ways. Now, how many balls remain? 9 balls remain. Each of the remaining 9 balls could go in any one of the 2 boxes. So, the remaining 9 balls could be given in 2 to the power 9 ways to B2 and B3. Yes or no? Shall I explain again? Clear? So, then the required probability, so these would be the favorable ways divided by the total number of ways, which is 3 to the power 12, would be the required probability. Yes or no? Right? Clear? Now, number 4. There are 2n plus 1 tickets consecutively numbered. So these are the tickets. There are 2n plus 1 tickets that are consecutively numbered. 3 are drawn at random. Find the probability that they are in AP. Now, first of all, in how many ways can you draw 3 balls, 3 tickets? Total number of ways of drawing 3 tickets is going to be 2n plus 1 C3. Right? Some of these ways would be favorable towards the 3 numbers being in AP. Right? We want to find the favorable cases for the 3 numbers selected being in AP. Right? So we want to find out in how many ways can I select 3 numbers A, B and C from this set. In how many ways can I select 3 numbers A, B, C from this set such that A, B, C are in AP. Yes or no? This would be the favorable ways divided by 2n plus 1 C3 would be the required probability. Now, if A, B, C are in AP, then it's like A plus C must be 2B. A plus C must be 2B, yes or no? So you don't have to select 3, you need to select only 2. Because if you have selected A and C, then B gets automatically selected. So it's about in how many ways can you select A and C. Because B gets automatically selected if A, B, C are in AP, right? Now, it's not like you can select any 2 numbers out of these 3. You can select only those 2 numbers that add up to an even number. Because if A plus C is even, can you have a number B which is commensurate? Because B is A plus C by 2. If A plus C is odd, then you can't find B an integer which belongs to the set. So it's about selecting 2 numbers A and C such that A plus C is even. So what is it that we want to eventually do? We want to select A and C such that A plus C is even. We want to select 2 numbers from the set such that A plus C is even. Now if A plus C is even, there are 2 possibilities. Both A and C even, or both A and C odd. Right? Now both A and C even. How many even numbers are there in the set? N even numbers. How many odd numbers are there in the set? N plus 1 odd. Now to select 2 even numbers, in how many ways can you select 2 even numbers? NC2. That means 2 even numbers could be selected in NC2 ways, or 2 odd numbers can be selected in N plus 1 C2 ways. That means the total number of ways in which A plus C is even would be this plus this. The total number of ways in which A plus C is even would be this plus this. So the favorable cases would be NC2 plus N plus 1 C2 would be the favorable cases, and the required probability would be favorable cases divided by 2n plus 1 C3. Yes or no? Let's look at the next one. A problem in statistics is given to 3 students, A, B, and C. The probability that A solves the problem is half. The probability that B solves the problem is 3 by 4. Probability that C solves the problem is 1 by 4. We want to find the probability that the problem is solved. The problem would be deemed solved if any one of them can solve, right? Now, first of all, I'll give you a detailed solution to this, but then I'll give you a simpler solution to this. The detailed solution, if nothing occurs to you, is the following. The probability that A or B or C solves is the probability that the problem is solved, right? This, from principle of inclusion exclusion, is going to be summation PA, that means PA plus PB plus PC, minus summation P A intersection B, that means A intersection B, B intersection C, C intersection A, plus summation P A intersection B intersection C. Now PA plus PB plus PC is known. Now in this, for example, PA intersection B is going to be what? A and B are independent events, yes or no? Because A and B both solve A and B is like PA into PB. It does not matter whether A has solved or not. The outcome of B will not depend on A. So A solving the event that A solves or the event that B solves are independent events. So probability that A and B solve would be simply probability of A into probability of B. Yes or no? Because they are independent events. Similarly, probability of B and C is probability of B into probability of C, because they are independent events. C and A is probability of C into probability of A. So these three terms will appear in this summation and only one term will appear in this summation. Now again, PA intersection B intersection C would be PA into PB into PC. This would be just one term in this summation, which would be PA into PB into PC. And you can plug in the values and get the probability that A or B or C could solve. At least one of them solves, the problem would be termed solved, right? This is one way. But this is not what you do. What you do is, probability that A or B or C solves is 1 minus the probability that none of them solves. That means A does not solve, A bar, and B does not solve, B bar, and C does not solve, that is C bar. Yes or no? Probability that A or B or C solves is 1 minus the probability that no one solves. A does not solve, B does not solve, and C does not solve. So which is like, again, if A, B, C are independent events, A bar, B bar, C bar would be independent events. So this would be 1 minus probability that A does not solve into probability that B does not solve into probability that C does not solve. Yes or no? Probability that A does not solve would be 1 minus half. Right? Probability that B does not solve is 1 by 4. Probability that C does not solve is 3 by 4. Yes or no? 32, 29 by 32 is the required probability. Right? Let's look at 6. Can I wipe this off? Number 6. Find the chance of throwing at least 9 in a single throw with 2 dice. These are 2 dice, D1 and D2. What's the chance of throwing at least 9? Sum is 9. Sum of the numbers obtained is 9 in 2 dice. First of all, what are the total number of outcomes that D1 can produce? 6. Number of outcomes that D2 can produce is 6. So total number of outcomes is going to be 36. All possible combinations. 36. All possible combinations. Right? We want to find the probability that the sum of the numbers obtained on the 2 dice would be at least 9, 9 or more. So when the sum is 9, for example, what are the favorable possibilities? 3, 6, 6, 3, 4, 5, 5, 4. Favorable possibilities are 4 in numbers. Favorable possibilities are 4 in numbers. Yes or no? Then sum 10. 5, 5, 4, 6, 6, 4. How many favorable possibilities? 3. Sum 11. 5, 6, 6, 5. That's all, right? So 2 favorable possibilities. Then sum 12. Only one possibility, 6, 6. That means 1. So then that, isn't it? The total number of favorable possibilities towards this event of obtaining at least 9 is 4 plus 3, 7, and 2, 9, and 1, 10. So the required probability is going to be 10 divided by 36, which is 5 by 18 is the required probability. Yes or no? Right? Seven. There is a single die D and we want to find the chance of throwing a 6 with a single die at least once in 5 trials. There are 5 trials performed with this die. 5 times it's rolled. It's rolled 5 times. We want to find the probability of getting 6 at least once. Can I say it will be the same as probability of not 1 minus the probability of not getting 6 even once. Probability of getting 6 at least once. Probability of getting 6 at least once in these 5 trials, can I say it would be 1 minus probability of not getting 6 even once? Yes or no? Are these trials independent trials? The outcome of T1 will not depend on T2, will not depend on T3, and so on and so forth. That means probability of not getting 6 in T1 is what? 5 by 6. Probability of not getting 6. Probability of not getting 6 in T1. 6 bar means not getting 6 in T1 will be 5 by 6. And probability, which will be the same as probability of not getting 6 in T2, is the same as probability of not getting 6 in T3. Yes or no? So probability of not getting 6 in T1, T2, T3, in not getting 6 in T1, T2, T3, T5 is what? Probability of not getting 6 in T1 into probability of not getting 6 in T2 into probability of not getting 6 in T3, which would be 5 by 6 because they are independent events. Not getting 6 in T1 is independent of not getting 6 in T2 is the same as not getting 6 in T3. So probability of not getting 6 in 5 trials would be 5 by 6 to power 5. Yes or no? So the required probability is going to be 1 minus 5 by 6 whole to power 5. Not getting 6 even once. Yes or no? Or the other way you could have looked at it is total number of cases, total number of possibilities is what? 6 into 6 into 6 into 6, which is 6 power 5. Right? Number of ways in which 6 does not appear in even one trial. Number of ways in which 6 does not appear in one trial also is how many? 5 to power 5. Because if 6 does not appear in T1, 6 does not appear in T2, 6 does not appear in T3, 5 ways that 6 will not appear in T1, 5 ways in which 6 will not appear in T2. So total number of ways in which 6 will not appear in any trial is 5 to power 5. Are the number of ways in which 6 will not appear in any one of the trials? That means from 6 power 5 total, I remove those cases in which 6 will not appear at all. Will give me those cases in which 6 will appear at least once. From the total number of cases, I remove those cases in which 6 does not appear even once. I get the number of cases in which 6 appears at least once. So these are the favorable cases. Divide by the total number of cases, which is 6 power 5, will be the required probability. Yes or no? Which turns out to be the same as this 1 minus 5 by 6 to power 5. Yes or no? Right? Number 8. If 8 coins are tossed, oh sorry, 2 coins, sorry, number 8 is different. If 2 coins are tossed 5 times, these are 2 coins, C1, C2, and they are tossed 5 times. They are tossed 5 times. If these 2 coins are tossed 5 times simultaneously, we want to find the chance that there would be 5 heads and 5 tails. Right? If they are tossed 5 times simultaneously, we want to find the probability that there would be 5 heads and 5 tails in that arrangement. Okay. First of all, each time the 2 coins are tossed, how many outcomes emerge? 4 outcomes emerge. Yes or no? Because there are 2 for this and 2 for this. So 4 outcomes emerge out of each toss. So 4 out of this, 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 right? So the total number of outcomes, unconditional outcomes, would be 4 to the power 5 would be the total number of outcomes. The total number of outcomes would be 4 to the power 5. Yes or no? Now, let me find out the favorable outcomes. Now, let's say I list out these outcomes. 10 dots, right? 10 possibilities. Very ancient, very primitive. Anyways, our honorable PM is taking us there. 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Now I want to find the favorable outcomes. That means these 10 dots, favorable outcomes would be like these 10 dots in which 5 would be heads and 5 would be tails. Those would be deemed as favorable outcomes. 10 dots arranged in a row, 10 dots arranged in a row in which there will be 10 entities, 5 heads and 5 tails. Yes or no? The question then is, given 10 things which are 5 heads and 5 tails, given 10 things, in how many ways can you arrange them such that 5 things are alike and of one kind and 5 things are alike and of a second kind? 5 T's will be identical, 5 heads would be identical. Yes or no? Right? So it's about 10 things. Number of favorable ways would be about number of ways in which you can arrange 10 things in which 5 would be alike and of one kind and 5 would be alike and of a second kind. Yes or no? This would refer to as the number of favorable cases in which 5 heads and 5 tails appear in various orders. Number of permutations of 10 things in which 5 would be heads, 5 would be tails. Therefore, 5 alike and of one kind, 5 alike and of a second kind. Right? So the required probability is going to be this divided by 4 to the power 5. So 10 factorial that's the required probability. Favorable by total. Right? Clear? Number 9. 8 coins are tossed. 8 coins are tossed. What is the chance that one and only one will turn up head? First of all, what are the total number of outcomes of this? 2 outcomes of this, 2 outcomes of this, 2 to the power 8. In how many ways will exactly one turn up head? 8 ways, yaar. Only 8 ways, isn't it? Exactly one turning up head is only 8 ways. Because that head could be here or here or here or here or here. Right? So there are only 8 cases in which exactly one turns up head. So favorable are 8 cases. So the required probability is going to be 8 divided by 2 to the power 8. That would be the required probability. Clear? Number 10. Four fair dice are rolled simultaneously. Four fair dice are rolled simultaneously. What is the probability that D4 shows a number appearing on one of D1, D2 or D3. Not exactly on one, but at least on one of D1, D2 or D3. Will it not be 1 minus the probability that D4 does not have anything in common with D1 and D2 and D3 and D4? And D3, sorry, and D3, D1, D2 and D3. The probability that D4 does not have anything in common with D1 is 5 by 6. Because if a certain number appears here, then there will be only 5 favorable cases for D1 such that D1 and D4 have nothing in common. Yes or no? Right? So 5 by 6 is the probability that D1 and D4 have nothing in common. 5 by 6 is the probability that D2 and D4 have nothing in common. 5 by 6 is the probability that D3 and D4 have nothing in common. So this is the probability that D4 has nothing in common with D1 and D2 and D3. Yes or no? Right? Clear? But we don't want this. We just want the complement of this probability. What we need is 1 minus this will give me the probability that D4 has something in common with at least one of D1, D2 or D3. Right? So this would be 1 minus 125 by 216. 91 by 216 is the required probability. U1 and U2 are two urns. So this is U1 and this is U2. Where U1 contains 3 white balls and 2 red balls, whereas U2 contains only 1 white ball. Right? Now, a fair coin is tossed. A fair coin is tossed. Now, there are 2 possibilities for the fair coin: a head and a tail. A head and a tail. If a head appears, then one ball is drawn at random and put into U2. That means one ball from U1 to U2. Right? If a tail appears, then 2 balls are drawn randomly from U1 and they are put into U2. From U1 to U2, 2 balls. Right? These are 2 possibilities. Now, after this event, this or this, a ball is drawn randomly from U2. Right? We want to find the probability that the ball is white. Right? After tossing the coin, either this happens or this happens. If this happens, then one ball from U1 to U2 is transferred. If tail appears, then 2 balls from U1 to U2 are transferred. And then, be it this case or this case, a ball is then drawn from U2 subsequent to this case or this case. We want to find the probability that it's going to be white. Clear? Now, very simple issue really. Okay. First of all, come down the tree. This or this. If it's head, the probability is half. And one ball transferred from U1 to U2. One ball transferred from U1 to U2. Now, one ball could have been white or it could have been red. Suppose the one ball drawn is white. Then the probability that it's white is 3 by 5. And if a white is put into this, then the probability that a white would be drawn would be 1, because there would be 2 white balls here. Or if one red ball is drawn, then the probability of drawing a red ball is 2 by 5. Now there is 1 white and 1 red ball. Then the probability of drawing a white ball would be half. Yes or no? This is one case. Or, so this is heads, or this. So half for this, right? Now 2 balls are drawn from U1 to U2. The 2 balls could be 2 white balls or 2 red balls or 1 white or 1 red ball, right? Suppose 2 white balls are drawn. The probability that the 2 balls are white, 3C2 divided by 5C2. 3C2 divided by 5C2 is the probability that a white ball, 2 white balls are plunged into this. Now the probability that a white ball gets drawn is 1, because now there will be 3 white balls here. That's 1. Now the probability that 2 red balls are transferred from U1 to U2 would be 2C2, which is 1, divided by 5C2. Now it has 2 red and 1 white ball. The probability that a white ball is drawn is 1/3. Or 1 white and 1 red ball. 1 white and 1 red ball can be drawn in 3 into 2, 6 ways. A white ball drawn in 3 ways, a red ball drawn in 2 ways. So a white and a red ball, independent events. So 6 ways, right? 6 ways divided by. Now there are 2 white balls and 1 red ball. I'm sorry, by 5C2, right? That's a probability of drawing a white and a red ball. Now a white and a red ball, 2 white and 1 red ball in this. So probability of a white ball would be 2/3. This would be the required probability, whatever this turns out to be. Have you, how much? 11/30? I do not know what. Huh? You've done this calculation? Okay, whatever it turns out to be. This is what it should be, right? A, B, C are 3 events. Probability of B is 3/4. Probability of A and B and C is 1/3. Oh, A bar C complement. A bar B intersection C complement is 1/3, right? And probability of A complement intersection B intersection C complement is 1/3. We want to find the probability of B intersection C, right? Now let me draw the Venn diagram. A, B, C. All right. Probability of B intersection C. Probability of B intersection C is this. Yes or no? This is the probability of B intersection C. This is the B intersection C area. I want to find the probability of this. What would that be? See, let me, this dotted region, let me call 1, and this region, crossed region, let me call this 2. Yes or no? Can I say that probability of B intersection C would be probability of B, which is this region, minus probability of this region 1, probability of region 1, minus probability of this region, which is region 2. Yes or no? Can I say all of this? Are you all convinced? Now, probability of B is given to be 3/4. Now, region 1 is what? The region common between A and B, which does not include C. Region 1 is what? Region common between A and B, which does not include C. That means A intersection B, intersection C complement, intersection C complement, which is this. Yes or no? I'll repeat. This region 1 is what? Dotted region is region common between 1 and 2, that means A and B, which does not include C. Isn't it? That's region 1. Are you all okay with this? That means P1 is this actually. This is P1 then, which is 1/3 minus. Look at this. This is that part of B which does not have A or C. Yes or no? Region 2 is what? That part of B which does not have A or C in it. That means part of B devoid of A and B. That means intersection of B with A complement and C complement, precisely. So this is region 2, which is this, isn't it? That part of region B which does not have A and C. A complement and C complement. So minus 1/3. This is the required probability. 1 by 12? Just feel comfortable with these Venn diagrams. Very simple stuff, right? Clear? Let's move to the next problem. 12 will appear on the 12th row, only in the 12th row. In the 12th row only, that's what it means. Two fair dice are thrown. What is the probability that 12 will appear in the 12th row? Right? 12th row. Two fair dice are thrown. That means the sum will be 12. Throw 1, throw 2, throw 12. These are 12 throws. Right? Each throw will have 36 possible outcomes. Yes or no? Each throw of rolling 2 dice will have 36 possible outcomes. So 12 throws will have 36 to power 12 outcomes. Yes or no? Right? So total number of outcomes are 36 to power 12. 36 for throw 1 and 36 for throw 2. 36 to power 12 outcomes in all. Yes or no? Now, outcomes in which 12 appears only in the final throw. That's what you want. Those are favorable outcomes. Outcomes in which sum 12 appears only in the 12th throw. Now there is only one way 12 could appear, 6 and 6, right? You want this 6 and 6 to appear only in this. Out of 36 outcomes here, there is only one for favorable for this, but 12 should not appear here. That means there are 35 outcomes for this, 35 outcomes for this, 35 outcomes for this, and one outcome for this. So number of favorable outcomes would be 35 to power 11 into 1. Yes or no? So favorable would be 35 to power 11 into 1. So the required probability would be 35 to power 11 would be the required probability. Right? Number 14. If M and N are two events, this is the sample space S. Two events. The probability that exactly one of them occurs, would be what? Only M occurring or only this occurring? Only M occurring or only this occurring? Now only M occurring is probability of M minus this region, which is M intersection N, minus probability of M intersection N, this is M occurring. Only M occurring. Or, therefore I'll have to add, or only N occurring would be this region, probability of N minus probability of this region, which is M intersection N, which is Pm plus Pn minus twice Pm intersection n. That's a probability that only M or N occurs. Yes or no? Only one of them occurring. Clear? Now also, what is this region? This is M intersection N complement. What is this region? M prime intersection N. Right? That means this region is also this plus this. So this must be actually equal to this. Yes or no? Clear? So option A is right, option D is right. No, sorry. Oh, M intersection N and M intersection N prime. Which is this? There is a misprint here. M prime intersection N. So, and let me tell you, think about it. Option C is also right. Yes, option C is also right. Option C will also, A will be right, C will be right, D will be right if the misprint is removed. M prime intersection N plus M intersection N prime should be option D. D would then be right. Think about it, C is also right. C is also right. Right. ABC are events such that PA is 0.3, PB is 0.4, PC is 0.8. And probability of A intersection B is 0.08. Probability of A intersection C is 0.28. Probability of A intersection B intersection C is 0.09. And it's given that probability of A or B or C is greater than or equal to 0.75. We want to find the interval in which probability of B intersection C lies. We want to find this is greater than or equal to something, less than or equal to something. We want to find these two values. Right? Principle of inclusion exclusion. Okay. Probability of A or B or C would be sigma PA, PA plus PB plus PC minus sigma P A intersection B, that means A intersection B plus B intersection C plus C intersection A plus summation P A intersection B intersection C. Yes or no? Now, what does this turn out? PA plus PB plus PC, 0.7 plus 0.8, 1.5. Right? This is P, which is 1.5 minus AB, BC, CA. AB, then this is 0.36, right? So 0.36 plus, suppose this is X, this is X. P, B intersection C, suppose that is X, right? Yes or no? I hope you realize what I did here. AB and AC added, which is 0.36 plus X, BC, which is X. I have to find the range of X. Clear? And then ABC, A intersection B intersection C is 0.09. 1.59 minus 0.36, 1.23. 1.23 minus X is A union B union C. Yes or no? But this is greater than or equal to 0.75. That's given. Yes or no? Where X is probability of B intersection C. So this is given to be greater than or equal to 0.75. That's given in the problem. So X 0.75. So X will be less than or equal to 0.48. Yes or no? Hey, but This will also be less than or equal to 1 because this cannot exceed 1. So this minus this should also be less than or equal to 1. So x less than 0.48 obtained out of this, and 1.23 minus x, which is this, will always be less than or equal to 1. So this gives me x greater than or equal to 0.23. Yes or no? So this x is greater than or equal to 0.23 and less than or equal to 0.48. Yes or no? That must be the interval in which B intersection C must lie. Clear? Is that all right? Can I wipe this off? Now number 16. A and B are two events. Odds against A. Odds against A are 2 to 1. 2 to 1 are odds against A. Right? That means against, right? Is it against? Right. That means probability of A would be what? 1 by 3. Very good. Right? Odds in favor of A union B. Odds in favor of A union B given to be 3 to 1. Therefore, probability of A union B would be what? Very good. 3 by 4. Right. If PB, what's given in the problem is PB is less than or equal to Y, greater than or equal to X, we have to find X and Y. Now, this is what? PA union B. PA plus PB minus PA intersection B. Right? Now, PB then would be what? 3 by 4 plus P A intersection B, A intersection B, okay, not given, A intersection B, 3 by 4 minus PA, minus PA, minus PA is minus 1 by 3 plus this, right, which is 5 by 12 plus A intersection B. So one thing, A intersection B is always greater than or equal to 0. So this is always greater than or equal to 5 by 12, yes or no? But can I say this just conceptually? Probability of A intersection B can never exceed the probability of A alone. Think of it. Two events A and B occurring together versus A occurring all by itself. There will be lesser probability of A and B occurring together than A occurring alone. Yes or no? Can I say this? I'm saying these are two events, A and B. Probability of A and B both occurring will always be lesser than the probability of A occurring. There will be lesser constraints in A occurring than in A and B occurring together. Yes or no? You know what I'm saying? So, this will always be less than or equal to PA. That means this expression will always be less than or equal to 5 by 12 plus PA. PA is 1/3. Can I say this? What? So this turns to 3, 4, 9 by 12, 3 by 4. This was PB. This was all PB. PB, which is this, PB, which is this, will always be less than or equal to 5 by 12 plus PA. PA is 1/3. This was PB. Yes. Fine. When am I denying that? But PB we do not know. PA we know. No, but that's conditional. We do not know if it's fixed. Right? So that makes it 3 by 4. So PB will always be greater than or equal to 5 by 12 and less than or equal to 3 by 4. Right? Got me, na? Diagram से, Venn diagram से भी obvious है. Number of elements in A intersection B will always be less than the number of elements in A alone, isn't it? Or B alone. Very simple. Without the diagram, it's logical to think. It's logical to think that way, isn't it? I mean, if the two of you had to go to the park and your probability of reaching the park is 1/3 and his probability of reaching, for whatever reason, is 1/5, then the probability that both of you reaching the park will be less than your individual probabilities, isn't it? Because there will be more constraints in the two of you reaching the park together. Objective to play cricket. You'll need balls to play cricket. Okay. So then, let's look at the next problem. A 6-faced fair dice is thrown until 1 comes. A 6-faced die, problem number 17. There is a 6-faced die which is thrown until 1 comes, What is the probability that 1 comes in an even number of trials? That means we want to find the probability that 1 comes in the 2nd trial, or the 4th trial, or the 6th trial, or the 8th trial, up to infinity. Yes or no? That means 1 should not come in the 1st trial, but then should come in the 2nd trial. That means the event should fail in the 1st trial. It can fail in 5 by 6 ways. In the 1st trial, it will fail in 5 by 6 ways, and it will succeed in the 2nd trial, which can happen in this way, many ways. So probability that it succeeds in the 2nd trial will be, it should fail in the 1st trial and should succeed in the 2nd trial. This will be the probability that one comes in the 2nd trial, plus it should fail 3 times and then pass the 4th time. It can fail in the first 3 trials in 5 by 6 whole cube ways and succeed in the 4th trial in 1 by 6 of 4 trials, now 6 trials. It should fail in the first 5 trials. It fails in the first 5 trials in 5 by 6 whole to power 5 ways and succeeds in the 6th trial in these many ways. Yes or no? Up to infinity? Because 2nd, 4th, yes, it's a GP series. Realize that this is the required probability. This sum would be the required probability, which would be 1 by 6, 5 by 6. It's a GP series with common ratio 5 by 6 whole squared. It's a GP series with common ratio 5 by 6 whole squared. Infinite GP series. A by 1 minus R. Right? A by 1 minus R, which is 5 by 6 whole square, which is 5 by 36 minus 25, 11. 5 by 11 is the required probability. Yes or no? Failing in the first trial, it can fail in 5 by 6 ways, but succeeding in the 2nd trial. Or failing in the first 3 trials. First trial, it fails in 5 by 6, 2nd trial in 5 by 6, 3rd trial in 5 by 6, but succeeds in the 4th trial in 1 by 6. So that's a probability of success in 4 trials. Probability of success in the 6th trial will be this, failing the first 5 times and succeeding the 6th time, and so on and so forth. So this constitutes an infinite GP series. That will be the required probability. 0.4. Yeah, close to half, you're right. So very close, yeah, very close, but not half. Not half. Okay, let's look at number 18. Let's look at number 18. Can I wipe this off? Number 18. There is a set A. Say the domain of a function. There is a set A which is the domain of a function f. And it's mapped to A itself. That means the codomain is also A. F A to A, F A to A, right? What is the probability that the mapping is an injection, one-to-one mapping? First of all, I have to find the total number of maps. Total number of maps, because each element could be mapped to any one of the n elements in this set, right? So this can be mapped in n ways, this can be mapped in n ways, this can be mapped in n ways. So total number of mappings would be n to power n, right? Now total number of one-to-one mappings, n factorial, because now injection means one-to-one. That means each element will only talk to one of the elements there, exactly one element, right? That means I have to arrange these 1 to n in these n spaces. In how many ways can I do that? N factorial. So number of one-to-one or injective maps is n to power is n factorial, right? So the required probability is going to be favorable ways, these are the favorable ways, one-to-one maps divided by the total number of maps. Now if I further said, what is the probability of creating injective maps from A to A? I'm saying, I'm revisiting this. I'm saying, what's the probability of creating one-to-one maps from A to A? One-to-one maps, injective maps only, which will be a subset of this n factorial, such that f of I is not equal to I. That means f of 1 is not 1, f of 2 is not 2, f of 3 is not 3. No. It's like, that means this cannot occupy this space. Derangements, very good, dude, very good. It's derangement of n things in n spaces, right? I not going to I, j not going to j. These are n letters in n envelopes. No letter going into the right envelope. I, the envelope I meant for the letter I. No letter getting into its right envelope. That is derangement of n things, yes or no? So the required number of favorable ways will no longer be n factorial, but will be less than n factorial. The required arrangements would be derangement of n things. These would be the number of favorable ways. In case you have forgotten, that's the derangement. That's a derangement of n things. No thing going into its right spot. So the required probability then would be derangement of n things divided by the total number of maps. If I said that A to A is mapped with only injective maps. Only injective maps are created from A to A. And so now it's conditional. In this case, the maps were unconditional. It could be 1 to 1 or many to 1. But now if I said only injective maps are created from A to A, what's the probability that this will happen? Absolutely. Now it's going to be dn by n factorial, because the new sample space would be n factorial. Yes or no? The new sample space would be n factorial, because I know that only 1 to 1 maps are created. Are you all there with me on this? Right now? Number 19. There are 4 white and 4 black balls. 4 white and 4 black balls in a bag, and 3 balls are drawn at random. 3 balls are drawn at random. If balls of the same color are identical, that means these are 4 identical white balls, indistinguishable, and these are 4 identical black balls, indistinguishable. Now if 3 balls are drawn, what is the probability that there is no black ball. Of the 3 balls that are drawn, what's the probability that there is going to be no black ball, given that these are indistinguishable 4 white balls and then indistinguishable 4 black balls, right? Now, what are the total possibilities when I draw 3 balls? I can have, say this is white and black. I can have 3 white balls and 0 black ball. This is one possibility. Or I can have 2 white balls and 1 black ball. That's a second possibility. Or I can have 1 white ball and 2 black balls. That's a third possibility. Or I can have 0 white balls and 3 black balls. Then there are only 4 possibilities. The sample space has 4 elements, yes or no? The sample space has only 4 elements, yes or no? Right? Out of which the only favorable, this is the only favorable member of the sample space in which no black ball has turned up. Therefore, the required probability would be 1 by 4. Yes or no? These are the only 4 possibilities. Because the white balls are indistinguishable, the black balls are indistinguishable. So choice of 3 balls is about how many white and how many black. Not which white and which black, but how many white and how many black will distinguish one selection from another. So there are only 4 selections possible, out of which this is the favorable selection. So probability would be 1 by 4. Yes or no? Got me? Then, like an earlier problem that I had, yes, then you will be selecting C2, C4, etc., C3. We've dealt with a problem in which now number 20. A point is selected at random from the interior of a circle. This is a circle of radius r, centered at O. This has, now the sample space is infinite elements, realize that. Right? If a point, how many points are there in this sample space? Infinite samples, infinite points in this sample space, right? And a point is randomly picked out from this. We want to find the probability that the point picked out is closer to the center than to the periphery. Is closer to O than to the periphery. So very simple. You draw a circle of radius r by 2. Then the point should lie here. The point should lie here. Right? Now, although infinite points in the favorable region and infinite points in the total region. But then the number of favorable cases will be proportional to the corresponding area. Right? Isn't it? So the required probability that it lies in this area would be area of this region divided by the total area. Divided by the total area. So the required probability is going to be pi r by 2 whole squared divided by pi r squared, which is 1 by 4 is the required probability. Yes or no? Right? (21) A coin is tossed n times. There is a coin C2, C3. It's tossed n times. What is the probability that a head appears an odd number of times? What is the probability that a head appears an odd number of times when it's tossed n times? What's the total number of possibilities? 2 to the power n, because tossed first time 2, tossed second time 2 possibilities, tossed n times 2 possibilities. So total number of possibilities are 2 to the power n are the total number of possibilities. Right? Now, let me calculate the number of cases in which head appears an odd number of times. That means there are these n times that it's tossed. So the number of ways in which one out of these n would be a head is nc1. Number of ways in which 3 of them would be heads would be nc3. You have to select 3 and make them head. Number of ways in which 5 would be heads would be nc5. Yes or no? And so on and so forth. Yes or no? These would be the favorable cases in which head appears an odd number of times. 1 time or 3 times or 5 times or 7 times. Yes or no? Absolutely, absolutely. This we have read is 2 to the power n minus 1. These are the favorable cases. So the required probability is going to be favorable cases 2 to the power n minus 1 divided by 2 to the power n, which is